Hello everyone. In this video clip, I'm going to share with you how to solve this clone SPM question. Now this question is asked in 2015 and this question is being modified. So the level of difficulty is a little bit higher than the SPM clone questions. If you want to know the similar clone SPM questions, which is less difficult, you can actually check out the link at the description box and see how to solve that question. Now, so let's start by analyzing the requirement of this question. Yeah. So in this question, we are given a cover of a lamp. All right. And then in diagram B is the net of the cover that was drawn on a piece of rectangular cardboard, and we need to maximize the usage of the cardboard, and from there we find the minimum value of the length and the breadth to the nearest integer. So over here, let's compare the corresponding sides of the diagram A and diagram B. So in this case, in diagram A, we have a small circular surface with diameter 15, which means we will have the radius of 7.5. And on the other hand, we have this big circular surface where the diameter is 25. In other words, the radius is 12.5. 12.5. Okay. And what other things that we know? We know that the small circular surface, the circumference, when we open up the lamp cover in the net, it will be forming the arc, the small arc here of this small sector, whereby the big circumference will form the big arc of the big sector. Okay, what else do we know? Okay, we do know that the slanting length here, okay, when we cut it open, actually form this one, the length between the blue arc and also the green arc. Okay, so what else do we know? All right, we do know that the arc here, the length of this blue arc is 2 times pi times the small r, which is 7.5. Because as I said, the blue arc here is actually forming the blue circumference. Likewise, go to our green arc. So the green arc will be 2 pi times width 12.5. So over here, we will have 15 pi and 25 pi. Okay, and what is the measurement of the red part? So the red part can be found. How? You see, if we just join the upright distance, which is 15, okay, over here, and therefore the slanting height here, okay, it's actually the hypotenuse if we form the right angle triangle between these two surfaces. So let me just extract the triangle out here. Okay, so what is the difference now? So this is 7.5, yeah? This is 7.5. This is also 7.5. Therefore, the remaining length here will be 12.5 minus 7.5, which is 5. Okay, and then what else do we know? We do know that this is 15. So in order for us to find the hypotenuse, okay, all right, we just apply the Pythagoras theorem. So over here, we will have 5 squared plus 15 squared, and then we square root it. That will be square root of 250. So mark it down here. There's a square root of 250, and we can also mark down over here. Okay, let me just get this away. All right, this will be square root of 250. Okay, and then what else do we know? Okay, just put back what we have erased just now. This is 15 pi. Okay, so now just focus in diagram B. What can we do about diagram B? We want to find out the minimum length and breadth. So we can study the breadth first. So the breadth part, okay, let me use this one. The breadth here, okay, the breadth here, basically it is the diameter, the radius of the big sector, isn't it? So if this is the big sector here, this is the big sector here, the big radius, sorry. So this is the big radius. So shall we use this? Okay, let's call this one R here, and the big one for small sector, yeah, the blue arc. The blue arc, we will have R theta, whereby the green arc will be R plus the red line, okay? R plus square root of 250 theta. Okay, this is what we get from the sector. And we equalize it to the value that we found using the formula of circumference. That means for this one, we also have R theta equals to 15 pi, and R plus square root of 250 theta equals to 25 pi. We have two variables over here. Okay, one is the R and one is the theta. Okay, to have two variables, we need to have two equations to solve this. So just nice, we have equation 1 here and equation 2 here. So in order for us to get rid of one of the variables, the easiest one is to use division. So we shall take equation 2 divide by equation 1. That means on the left side, R over square root of 250 theta divided by R theta equals to the right hand side, which is in proportion, 25 pi over 15 pi. And we can simplify the theta away, and we simplify this a number away. We have 5 over 3, okay? And then we cross multiply the whole thing. So we will have 3R plus 3 times square root of 250 equals to 5R. So we can find R first. So this one bring over. Therefore, 5R minus 3R equals to 3 square root of 250. So 2R equals to 3 square root of 250. Therefore, we found the R. The R will be 3 times square root of 250 and then divided by 2. Use the calculator, we have 23.75. So over here, we have 23.75. That is this one, the small radius of the small sector. So for the big sector, it will be, so R for the big sector, okay, so it will be 23.75 plus square root of 250. So using calculator, we will get 39.52. Okay, and notice that the radius of the big sector will be the measurement of the breadth, for the breadth, okay? Therefore, the breadth, okay, the minimum breadth will be 40 cm because we want to round it off to the nearest integer, okay? Because as we sketch this arc, all right, up to the maximum. And then when we continue, this will be the maximum here. So it will form the breadth over here, all right? And we want to bring in, round off to the nearest integer. Therefore, minimum breadth is 40 cm. So once we have found the breadth, now we can look for the length. How do we find the length? To find the length, we need to know the length of this side. So how do we find this? Do you notice that it actually formed a right angle triangle over here? Okay, so we shall use this right angle triangle here because let me just get the right angle triangle out, yeah? All right, so let's move slightly towards the downwards a little bit. Okay, all right, let me just get the triangle out. Okay, we know that this one is the big R, coming from the big R, isn't it? Yeah, it's actually the radius of the big sector. And the radius of the big sector, which is found to be 39.52. Okay, so we need to know this one. And the angle used must be this lah. All right, but I do not know the angle. But this side that we want to find, according to the angle, it is the adjacent side. So in order for us to find A, we need to have the angle. But how do I find the angle? We can use the S equals to R theta for the blue arc. Okay, let's say from which equation? From equation 1. You still remember what is equation 1? The equation 1 is actually the arc length of the blue arc. R theta equals to 15 pi. Okay, we shall use that. So R theta equals to 15 pi. And then theta we don't know, but R we already found. It's here. R is actually 23.75. So to find theta, we just need to take 15 pi over 23.75. Therefore, by using the calculator, we shall get 1.987 radian. Okay, and then if we know that this is 1.987 radian, we want to find the angle beside it. Therefore, let's label this one. Okay, since this is theta, we label this as alpha, yeah? So call this alpha. Therefore, alpha will be 3.142. Why? Because it's actually the supplement angle. Okay, the supplement angle, that means they form 180 degree. 180 is equivalent to 3.142. So 3.142 minus 1.987 radian. Okay, all right. Now, I foresee that I need to use the the trigger ratio. So I change this one into degree at the same time. So times 180 degree over the pi, which is 3.142. So we will get 66.17 degree for this angle alpha. Now, how do we use this angle alpha to find A? All right, A and hypotenuse. So ka. So according to so ka twa, we shall use ka, the function cos. Therefore, the function cos 66.17 degree equals to adjacent over the hypotenuse, which is 39.52. Therefore, to find adjacent, it will be 39.52 times with cos 66.17 degree. And by using the calculator, we get the answer 15.97. Okay, and therefore to find the minimum length, it will be taking the breadth, okay, or sorry, the radius, okay, the radius of the big sector look at the diagram. The radius of the big sector plus the A that we have just found. So 39.52 plus 15.97. So we have 55 point, by using calculator, yeah. Hold on, 55.49. Okay, and therefore we round it off. The length, round off to the nearest integer, 56. Everything in cm. So we have just found the minimum breadth and length for part A. Now, so for part B, find the area of the unused cardboard. So the area of the unused cardboard will be much easier now. We just take the area of the cardboard minus area of the net of the cover length. So how do we do that? So area of unused cardboard will be area of the rectangle minus area of the net. Okay, how do we find area of the net? Now, okay, let me just draw the diagram here, a quick one. So we have, okay, we just take the area of the big arc, take away the area of the small arc. That will be the arc of the net of the lamp cover. So in that case, we do like this. So the breadth will be 40 times the length will be 56 minus area of the net will be area of the big sector minus area of the small sector. Okay, let's solve that part. So 40 times 56. Okay, using the calculator, 40 times 56, we have 2,240. Okay, solve this one first. Now the area of the big sector will be half r squared theta. So the r will be the 39.52, yeah, here, just in case. All right, so the big R is 39.52, the small r is 23.75. Okay, put it here, big R, 39.52, small r for the small sector is 23.75. So half r squared theta. So 39.52 squared theta, and the theta, the angle that we already found, which is here, 1.987. Okay, so times 1.987. Take 4 significant figure. And minus half r squared, the small sector will be 23.75 squared times 1.987. Okay, so with this, by using the calculator, okay, our answer will be 1,244.88 cm squared. Okay, all right. So that's all for the solution for this question. I hope it helps you, especially the part A. Right, so this is the part that you have to be patient and transfer the important measurement from diagram A to diagram B. Okay, so with that, should you have any question, you can just leave your question in the comment area. I'll come back to you as soon as possible. So thank you.